Hi guys. In the last day, we finally completed the live streaming inference using YOLO-NAS. So I told that after that, our next step is to log these particular values like bounding boxes, scores, confidence into a DB. So that's what we'll be trying to do today. So yeah, let's get to that. So inside the YOLO-NAS.py file, there's a file called dictate.py. So that's where the whole magic happens. Where the steps of post-processing, pre-processing is being conducted. So I'll be checking out the detect function inside the dictate.py file. So inside the dictate.py file, you can see that there are like multiple processes that is happening like NMS and all. So inside that, the values that is desirable for us is the boxes, scores, labels. So that's what is more desirable for us. So I'll be trying to log in uh, the labels and scores first, so that we can identify what is good for us. So yeah, print label scores. Yeah. So once you fi- run the script, you can see that the my face is being identified and the score is being printed. And when I show it my mobile phone, it is mislabeled or misdictated. So that's where the score part comes in. As you can see, when I show it a spoon, it is being misstated, but the confidence there is really low, but the spoon has a higher confidence of somewhere around 70 or something. So we can put at a threshold there and choose, or even an LLM can choose between the objects being identified in that particular frame. That is the whole logic of identity, putting the labels and scores along with it, so that we can identify which is actually being detected rather than being mislabeled. So that is why we are keeping the scores and labels together. Apart from that, it looks like we could also use help of time as well, because LLM is really dependent on the time series data. Here we want time series data because this is like a series logging of what is happening inside in real time using a webcam. So the data that is being recorded by webcam is being logged into an database using an object detector. So we are in need of time, so that LLM can say what happened at what moment of time. For example, a power vase fell down at 11 o'clock. So we can ask the LLM, when did the flower vase fell down? So the LLM can reply us with the time of that incident. So for that, I believe the sequence of time is also required. So for that, we are importing time using the time library, and this will mostly return the time as an Unicode, because I don't know the exact word for that, but that's like a term. It's in seconds, so we need to convert that into actual date time using datetime library. So yeah, we are converting that to datetime using the datetime library. uh, so for that, the it looks like we can directly use it and we can log it out. Yeah. So yeah, that is being done. Once that is print, we can check out what is happening. So yeah, looks like our initial aim is completed. We have given the label, the scores, the time, uh, in the required format. So now our requirement is to look into how we can convert this particular part into an actual what db. Like we are just logging in the terminal, that is not what we require. We need to convert that into an db. So we asked ChatGPT how to log the live feed into an db and which db is preferred. So it said a couple of dbs, and but for structured data as well as time series data in a moderate traffic, the preferred db is Postgres. That's what ChatGPT said. So we will be looking into Postgres SQL in this particular project. So yeah, I gave it our function, the detect function, and asked ChatGPT to generate the code using that particular function to log the data into DB. And ChatGPT give it an answer. It includes couple of files, including logger, db.py, changes in the detect functions. So it is actually not exactly what I want. I also wanted to include something called as SQL Alchemy. So SQL Alchemy is somewhat like a interface between Python and SQL, where you can type out the things in Python, and it will be converted into SQL queries, and it is much more easier for us to use Python, like for me at least, to use Python instead of SQL. I'm not an expert in SQL. So that's when I asked ChatGPT to give me the result using SQL Alchemy. So ChatGPT made necessary changes and gave us the functions. And in here, you can see that there are a couple of things that is not required for us, like camera ID, the image URL. Bounding box might be required, but other than that, rest things are required. But yeah, image URL and all are not required. And there are functions called to create DB. There is like model structure, logger. So these functions are required to set up a DB, especially the model structure and the create DB function. So we will be using that to create our DB, and we'll be trying to log our values into DB. For now, we will be working with our current hardware itself. Like the camera, the DB, or is in my laptop only. So I generated the DB using the particular functions or the files given by ChatGPT. There were a few errors. That's when I use cursor. Right now, I'm just connecting to my DB using the PSQL command. The command was given by cursor only. So yeah, you can see my DB there, and I'll be just checking what all are available in the DB. So I always have an confusion between forward slash and backslash. So yeah, as you can see my DB there. So yeah, we have created the DB. Now we will start logging the values from our particular camera to this DB. That is what our aim is. I hope after that we can move on to Raspberry Pi and sending the values to our DB. So that will be coming soon. Next class, in the next video, mostly we will be logging the values to a DB. I think that will be a good exercise, because I have done that, but not on a live stream. So yeah, not a live streaming data. So that will be really interesting to see. Yeah, thank you guys.